I have seen this image of a transformer proposed in the paper, Attention is All You Need. And a transformer is basically the underlying architecture for what runs ChatGPT, Grok, Claude, some of these other models. But this image is a little bit confusing, so let's simplify it. This is a better representation of what's going on. There's two main components to the transformer, the encoder and the decoder. Starting with the encoder, the main job for the encoder is to get a deep understanding for what the input text means. So say you give ChatGPT the prompt, how many miles should I run this week without getting too tired? What is generally recommended? The model actually has no idea what this means. So what it does is converts this input to tokens and then embeds them as a vector for meaning and position. Next, this will move into the self-attention layer and then move through the feed-forward phase. These all have distinct meanings, which I will cover in detail in other videos, but the main job for the encoder is to understand what you're saying in terms of numbers instead of actual meaning the way we comprehend it. To the decoder actually has a lot of similar components to the encoder, but the main job for the decoder is to give you output, aka respond to your prompt. So the decoder does have the self-attention layers. It has encoder decoder attention, so it can actually see what the encoder output, and then it also have feed forward phases, and then at the end what it's doing is creating a probability distribution for the next likely word. And every time it generates a word or a token, it'll repeat this. But follow for more. I will be going into further detail on the specific components that make up the LLM or the transformer architecture.